Hello everyone and welcome to our Git tutorial. Git is one of the most widely and powerful tools used in the software development today. In fact, it is the de facto version control system used in almost all major corporations today. Whether you are a developer, designer, or just curious about how version control system works, you are in the right place to start your journey into learning how Git can enhance your projects. Imagine you are working on a project where multiple people are editing the same files. Or even when you're working alone, you need to make sure that you can safely undo the changes you have made in case something goes wrong. That's where Git comes in. Git is a version control system that helps you manage and keep track of your code changes. What does that mean? Git takes snapshots of your files as you work on them and allows you to revisit them later if needed. For example, you have been working on a project for the last few days and you realize today that your builds have been failing for the last 2 days. So that means that something you did 2 days ago broke the system. What was it? To be honest, most of us don't even know what clothes we wore yesterday, let alone 2 days ago. Git saves the day here. Using Git, we can figure out what exactly we did 2 days ago and fix that problem. This is just one of the many things where Git helps us in our software development process. In this tutorial, we will talk about the following topics. 1. Introduction. We already did that. Then we will talk about how to install Git. After that, we will see how we can configure Git. Then we will look at some basic Git commands. After that, we will talk about branching and merging. And lastly, we will look at remote repositories. So let's get started. Before you can start using Git, you need to have it on your computer. First, we can check if we have Git already installed. You can do that by opening command prompt on Windows, Shell in Linux, or Terminal in Mac OS X. On Mac, open your terminal and type in the command git ---- version. If it shows you the Git version, that means Git is already installed. If not, we will use homebrew to install Git on our computer. To install Git, use the command brew install git. Because I have Git already installed on my computer, I get a message that it is already installed. If you do not have it, you can just follow the prompt. You will have Git installed on your computer. For Windows, you go to the download page. The link is in the description and click on Windows. And then you download the appropriate installer for your computer, 32-bit or 64-bit. Double click it and then just follow the instruction on screen. And soon you will have Git installed. For Linux, you go to the same download page and click on Linux. And then you choose your distribution of Linux and run the command mentioned there. And this will install Git for you. Once you have Git installed, it's a good idea to configure your name and email address because Git will embed this information in every commit you make. Use the following command to set up your username. After that, use the following command to set up your email address. You can use the command git config ---- list to see the variables that you just set. Remember, this information will be included in every commit that you make. This is how you can identify who made a particular change in any file. Once we have Git installed and configured, let's see how we can use Git and learn some basic commands. Let's start by creating a new directory, new_project. And we go in the directory and run the command git status. You will see that it is not a Git repository or that it is not managed by Git. The first thing we need to do if you want to manage this directory as a Git repository is run the command git init. After that, we can run the command git status again and we will see that this directory is now managed by Git. If you look at the contents of the directory using the command ls-als, we can see that there is a new directory .git. This is also an indicator that Git is managing this directory. We can quickly look inside this new directory. You will see that it has a lot of stuff. Never ever change or edit anything in these files unless absolutely necessary because this will break your Git. Let's create a new file, index.html. I will create it in my terminal and later we'll move on to our Visual Studio. If I do a git status now, you can see that Git will say that there's an untracked file which it doesn't know about. Let's move over to Visual Studio and add some content in this file. So I added a title, a heading and a paragraph, then I can save it. Let's go back to our terminal and run the command git status. You will see that the file is still untracked. We can use the command git add file name or the shortcut dot, which will add every file that is below this directory to add it to Git. If we do a git status now, we will see Git has a new file, but it has still not been committed. We can go and commit this file using the command git commit -m to add a message to that commit. And please always use a meaningful message to every commit, because this will help other developers to know what you did and why you did it. So let's add something like added new index file. If you do a new git status, you will see that everything is clear, everything is committed. And if you do a git log now, you will see that author me with this email address added a new file with this message. Each commit gets a unique ID. You can use the command git show and the commit ID to see exactly what was done in this commit. If you do that, you can see who was the author of this commit and what was done. You can see that a new file index.html was added, and the plus and the green indicates the text that was added in this commit. Now let's go and edit this file again. So I will go in my Visual Studio and I add page title new, and this is a heading new, and I will go and add a new paragraph, the second paragraph. Go back to my terminal, to a git status, and you can see that index.html has been modified. You can even use the command git diff and the file name or dot for every file below this directory to see what was changed. And you can see it exactly tells you what was changed, what was deleted and what was added. So now we go and add this file back to Git. You can do a git status and you can see that the file was modified. Green means it has been added to Git. You can use the command git restore --stage to remove it from the status added, and then again use git restore to remove all the changes you made. Let's do that. So you do git restore --staged. I will use dot. If you do a git status, you can see that file is back to red. That means it has not been added to Git right now for committing. We can use the command git restore dot to undo all the changes in the file. Let's do that. If you do a git status now, you will see that there's nothing to commit, there are no changes. If you move back to the Visual Studio, you can see that all the changes that I made are gone. Now let's make the changes back to the file and do a second commit and look at the log, how it looks like. Now that I've made the changes, do a quick git status. The file has been modified, so I will add the file. After that, I will do a commit with the message I've committed, and then now everything should be clean. Let's look at the log now. You can see that there are two commits now. One commit was made a couple of hours ago, added new index file, and the new one I just added. If you look at the new commit, you can see that a file has been edited. And here it shows the diff. It shows which line has been removed and which lines have been added. We looked at some basic git commands. Now let's talk about git ignore. Sometimes you want some files not to be managed by Git. For example, log files. So how do we ignore them? How do we tell Git to not add these files to Git? The answer is git ignore. What we do is we create a new file which is called git ignore. Once we have this file, we can edit this file and write the names of the files with wildcard that should be ignored. Let's do that in Visual Studio. Now we are in Visual Studio, so let's go back to git ignore and add something like star.log. Once we have done that, every file with the extension log will be ignored by Git. So now let's go and add a new file in Visual Studio and name it test.log. Let's go back to Git and see what Git status shows us. You will see that it shows as untracked file only .git ignore, even though the file test.log is existing there. And the reason is that star.log has been mentioned in git ignore. So git ignore is a powerful way of telling Git the files that should be ignored. Let's commit this git ignore file. As you can see, I made a spelling mistake while writing the message for this commit. How do we fix that? Let's look at the log first. You can see that it shows a message with a spelling mistake in the logs. How do we fix that? So Git commit has a special option which is --amend, where you can write a new message which will replace the message for the last commit in your Git repository. This is done. Let's check out our log again. You can see that the message for the last commit has been updated. Let's do a recap of the commands we learned in the last section. We looked at git status, which tells us the status of the working directory, if there's some file that is open to be committed, or if there's an untracked file. Then we looked at git init, which will convert any directory that you have on your computer into a Git repository, if it isn't already one. Then we looked at git add. This will add an untracked file or a file with some changes to be committed into Git. Then we looked at the shortcut dot, with which you can refer to all the open files instead of just a single file by name. It's really helpful. We also looked at the commit command, with which you can commit your changes into Git, and that will create a snapshot of your working directory. We also looked at a variation of commit command with --amend, where you can change the commit message in case you made a mistake. We looked at the log command, which shows you basically all the snapshots that are available in your Git repository. We looked at the show command, which shows you one particular Git commit, where you can see who made this change and what exactly was changed. We also looked at the diff command. The diff command is very useful because you can compare your open changes with your last committed version. You can also use diff to compare two different commits, but that's a little bit more advanced. We also looked at the restore command, where if you're not sure if you want to commit your changes right now, you can restore your changes back to untracked or to your previous version. We also talked about .gitignore file, which is a really helpful and a necessary tool with which you can tell Git about the files that you would like to be ignored and not to be tracked by Git. Now that you know some basic Git commands, let's explore one of the most important features of Git, that is branching and merging. These features allow you to develop new features, fix bugs, create hotfixes, or just experiment with your project without affecting the main area of your project. Let's check out Git branch in action. If I now do git status, you will see that it says I'm on branch master. This is the default branch that Git will create for you when you create a new repository. If you run the command git branch, you will see it lists the branches that my repository has, and the one with star is the one I'm using. Currently I only have one branch, so let's create a new branch. To create a new branch, you use the command git branch and the branch name. Once I do that, and I run the git branch command again, I see that I have a new branch. To use this new branch, I have to use the command checkout. By using the command git checkout new branch 1, Git will switch to branch new branch 1. And if I do git branch now, I will see that I have two branches and I'm currently on branch new underscore branch underscore 1. By the way, if you want to create a new branch and simultaneously start using it without using two commands, git branch create new branch and git checkout, you can use the command git checkout -p and the new branch name. Let's see it in action. Once I do that, it will create a new branch and switch to it immediately. Creating a branch creates a movable pointer to the commit where you were at the time of creating the branch. So right now I'm in the branch master. If I do git log, you will see the top commit, the last commit where I created the two branches, is mentioned in there. So it explicitly says that this is the commit where I'm right now. That's where the head is. And this is the commit from which the master, new branch 2 and the new branch 1 was created. Now let's play with it a little bit. We go in the new branch 1 and make some changes, commit, and see that this experimental change does not affect the master branch at all. So the first thing I will do is go into my new branch 1. Once I'm in the new branch, I will create a new file, experiment.txt. I can go back to my Visual Studio and write some text in there. Test 1. Going back to my terminal, I can see that there's a new file now, experiment.txt. Let's add it and commit it. I have added and committed that file. If you look at the status now, everything's clear. If you look at the log, it will say then there's a new commit with my commit message and the new branch 1 has moved to this commit. And the master and the new branch 2 is still at the older commit. If I now go back to my master branch and check out the log, you will see that the experiment commit that I made is not included here. So my master branch is still clean and has not been affected by my experiment or any other work that I will do in my future branches or new branches. You can see in Visual Studio that the new file we created, experiment.txt, is not there anymore because we are in the master branch. Now let's talk about merging. Let's say you're happy with your experiment or the feature you were working on or the bug that you were fixing, and you want to bring it back to the main branch so that this can be deployed and other users have access to it. This can be done using merging. Right now we are on branch master and we want to bring the changes that were in the experiment branch, the new branch one, back into master. So let's first make sure these changes are not there. So we do a git log and you say the last comment was added git ignore file. To merge changes from one branch to the other branch, we use the command git merge. Use the name of the branch from which the changes will be merged into the current branch, being the master branch. So the command is git merge new branch one. And remember, we are in branch master. Once we do that, Git tells us that our commit has been fast forwarded and a new file has been added. If we do a git log now, you will see that a new commit has been added to our master branch and the commit is also in the new branch one. If you look at the last commit using the command git show, we can see that a new file experiment.txt was added. So that's how you merge branches and bring changes from a branch into a different branch. Just so that you know, sometimes there will be merge conflicts because it's possible that two different developers are working on two different branches on the same file. Some of the times Git will figure out the differences automatically and do an automatic merge. But sometimes if both the developers have changed the same section in the same file, Git will not be able to resolve this conflict. In that case, the merge will stop and Git will ask you to manually resolve this conflict. And this is a good time that you talk to the other developer and see that both the relevant changes are committed and nothing is lost. Now that you are master of basic Git commands and know branching and merging, let's talk about remote repositories. Remote repositories allow you to collaborate with other developers. Remote repository is exactly what the name says. Remote repository is not something that is on your local machine, but it is hosted somewhere remotely. GitHub is a good example of that. And most of the companies that you will work for will have their own internal hosted repositories, for example, Bitbucket. Remote repositories are almost always backed up, so that's an added advantage of using remote repositories. When you start working on a new project, the Git repository will usually already exist. So somebody will give you the URL. To get the contents of the repository on your local machine, you use the command git clone. Obviously, you have to set up your SSH key and security and everything beforehand in Bitbucket or GitHub. I've already done that. I'm using a URL from GitHub right now. So I do git clone and the URL of the repository that I created for this tutorial. I do that and you can see that Git will clone that repository on my local machine. If I do ls now, you can see a new directory has been created. I can go into that new directory and then look at the contents of this repository, and these will be exactly the same on the branch where I'm right now as in GitHub. If I do git status, I can see that I'm on branch main, which is the default branch in GitHub instead of master. This is how my repository looks like in GitHub. As you can see, we have exactly the same files. Let's go back into Visual Studio and edit an existing file and create a new file. So I'll go in there and edit the title, add a new file, save it. I'll go back to my terminal, do a git status, and I can see one file has been modified and there's a new untracked file. Let's do a quick diff and see that one of the file was edited. The file that was created new doesn't have a diff because there was nothing to compare it. Now we can add this to Git and commit as usual. So I just added the files and now I'm committing it with some message. Now how do these files come from your local machine to the remote repositories? Command to bring your local changes to a remote repository is git push. If I do a git push, you can see that some changes were pushed to the remote repository. Let's check them out, how they look like on GitHub. In GitHub, you can see our new commit and the file that was edited and the new file. You can even click on the commit and it will show you exactly what was done. So the file was changed and this file was added. We just saw how you push your local commits to the remote repository. Now let's look at how you get the changes from the remote repositories to your local machine. Let's say another developer has made a change. Let's look at the test.txt file. There has been a new change on it with the commit message update test.txt. If you look at it, you can see a new line was added, test 2. We can see in Visual Studio that these changes are missing on our local machine. The command to get the remote changes on your local machine is just the opposite of push, which is pull. So it's git pull. You do a git pull and you will see that test.txt has been updated. Let's go back to our Visual Studio and we see that the file has been updated and we have the latest changes. Let's check out a couple of more commands that you will need in your day-to-day life working with Git. Let's say there's a new branch which is called new branch _1. Now, how do we get this branch on our local machine? Let's try with git checkout new branch _1. We get an error because Git doesn't know about this branch. To get a new branch that our local Git doesn't know about, we have to use the command git fetch. This will fetch all the new branches that are on the server that we don't have right now. Now we can do git checkout and we can switch to this new branch. Now let's talk about the case where a new branch has been created locally but the remote doesn't know about it. Here I'm going to create a branch new _branch 2. After I have created it, I will try to push it. I get an error that there is no upstream to this branch. That means our local branch doesn't know where to push it to. The good news is that Git gives us the solution of this problem. It says here, use git push -set upstream origin new branch 2. I'm going to use this command to push now and we can see that it was pushed successfully. The next time I want to push, I don't have to do this set upstream again because this has already been set for me. We can also check the remote repository using the command git remote -v. As you can see, the fetch will be done from this URL and it will push to this URL. That wraps up our tutorial on Git. Although I have to say, this is only one side of the coin. To use Git effectively, you need to use some standards. For example, Git flow and using pull requests and using some securities. For example, not allowing everybody to pushing directly to your branches like develop and master. I will create a tutorial on this in a future version. If you liked what you saw, like and subscribe and leave a comment. Thank you.